Hello everyone, welcome to the third episode. Today we'll be talking about the simulations and control department.
At Forze we make a lot of iterations in our design process. To test and improve our design, we simulate driving the car.
Simulating instead of physically testing saves a lot of time and money. In order to do that, we have two main types of simulators.
Now, Alvaro and Sander of the Simulations and Control Department will show you how they work their magic.
Hi, my name is Alvaro and I'm a simulation and control engineer here at Forze. As a simulation and control engineer, my job is to first make simulations of the car at a high level that we can use to provide different departments within the team with information about how the car will perform and help the driver to get acquainted with the new car before it's actually built. Next to that, we use these simulations to design control systems, to actuate all the moving parts in the car and make sure that it performs as we need it to.
Hey, I'm Sander. I'm a colleague of Alvaro. I'm also in the simulation and control department. And as Alvaro already told you, a part of what we do is in the elite simulation. We have two simulators, the 3D simulator and the 1D simulator. The 3D simulator is really what you would think it would be. It's a racing simulator with a driver in it, driver and loop simulator, to get direct feedback. And the 1D simulator is more abstract. It's a MATLAB script we run and it's without a driver and we can get fast information about what our car will do. As an input we give some simple parameters like RPM curves for the motor, the mass, what our energy buffer is. And for example, if we change something in the energy buffer, we can immediately see what the effect is going to be in our lap times, what it's going to be in our speeds, in the straights. We interface a lot with the rest of the team. Before the car is even built, we already give feedback on the design they make. We can easily see trade-offs in the data we gather from the 1D simulator, and it's really vital to get the best racing car we can.
Once we found something specific that we want to examine further, we can step over to our 3D simulator, which has much more complicated and realistic models of, for example, the suspension and the drivetrain. These more complicated models allow us to actually see if what the 1D sim predicts lines up with what we actually expect the car to do, and hopefully in that way validate that what we aim to achieve is actually realistic. An example of something we can validate in 3D sim is our energy strategy. Once we found an energy strategy that seems to be optimal in the 1D sim, we can use the more elaborate and complex models of the 3D sim to actually validate that this energy strategy is beneficial to performance of the car. For that, we can use the driver, who can then come over, familiarize himself with this energy strategy and see if this is actually something we can use in the car. In addition, because the model of the car in the 3D simulator is so elaborate, it also allows us to tune, for example, stability control and torque vectoring devices that can enhance the performance of the car on track. In this process, driver feedback is critical, and that's why it's important that the 3D simulator is as realistic as possible, so that the driver can give us feedback on what he thinks the car should or has to be doing before we actually go over to production.
While working on the sim, we take a lot of input from our drivers. One of our drivers is Jan.
Hello, my name is Jan Bot. I'm one of the drivers of the Forze IX racing team. I've been a driver since 2011.
So, how do you make sure that the simulator represents the real car on track?
Of course, we have a lot of experience now with how the cars operate on the track. So when we're driving in a simulator, we can quickly see where the reality is a bit different from the simulation, or where we think that the actual car is also acting different. And then step by step improve the simulation bit by bit.
Now we can simulate the car accurately. How can we use the sim to get the maximum performance out of the car?
That's where the energy strategy management is really key to lap time. We try different strategies in the simulation, such as regen power, trying different braking points for the regenerative braking. And once we've defined an optimal strategy for the current specification of the car, we test it out on the track and try to achieve the best lap times.
So you've optimized the strategy beforehand, but on a race, things always go different than planned. How can we deal with this?
In a racing weekend, we've taken the whole sim setup to the track, and we've even been able that during a racing weekend, when some of the parts in the car started to fail or perform less than expected, we've been able to replicate those problems in the simulation. So for instance, decrease the fuel cell power or decrease the powers that the electric motors could develop, and then redefine our optimal strategy for the actual race, which was, for instance, the next day. And therefore, it was really an essential part of our success in the race.
As you all have seen, we have a 1D sim to quickly test rough design iterations and a 3D sim to fine-tune our design as well as to train our drivers.
From these simulators, we get a lot of feedback, which we can use to improve the design of our car before we go to production.
Thanks for watching the third building vlog. If you have any questions, feel free to comment down below.
Like and subscribe to our channel to stay in the loop. We have some really cool parts coming in the near future and you don't want to miss that. See you in the next episode.